All right, so in this video, I'm going to show you how to solve homework 4. So the first problem was about dice rolls, and all I wanted you to do is to show me if you add multiple dice rolls, the distribution looks like a normal distribution. So as you keep adding more and more dice rolls, the distribution goes from a uniform distribution and converges to a normal distribution. Okay, so first of all, how to generate the dice roll. So these are the inputs in our model, and we do have 3 inputs. We could do another die roll, but it's not mandatory, right? You can just do 2 of them. You can use your cheat sheet to figure out that the die roll, the distribution for the die roll is basically a uniform distribution between 1 to 6, and it is a discrete uniform because you can only take numbers 1, 2, 3, 4, 5, 6. You cannot take anything between 1 and 2. And to do that, we are can use the function called ran between. Ran between and then 1, 6 because you are going to only get numbers from 1 to 6. Same thing for die 2, ran between 1 to 6, ran between 1 to 6, and again ran between 1 to 6. All right, again, if you just do 1, 2, 3, die 1, 2, 3, that's gonna be absolutely fine. You don't need to do the die 4. All right, now in our output, the first thing to create is the sum of 1, which means, so what does the sum of 1 die roll mean? It just means that any one of the die rolls. So to this, you can link to any one die rolls, okay? It doesn't matter which one you link, you're gonna see the same result. Let me just link die 1 to be, just to be consistent, and then I'm gonna use die 1 and 2 for sum of 2. So you're gonna do sum of any 2 die rolls for this again. I am going to do die 1 plus die 2, but you could have done die 2 plus die 3 or die 3 plus die 4. It would be the same. Same with sum of 3. I'm going to do die 1 plus die 2 plus die 3. All right. Okay, so next are my simulation. So simulation trial. And I'm going to do die 1. So all my inputs and all my outputs. Sum of 1, sum of 2, and sum of 3. All right, you're going to start with 1. And I'm going to get 1 to 5,000 in this case. But if your computer is slower, then you feel free to do just 1 to 100. You will not be able to see central limit theorem, but I mean more convincingly, but you should still be getting the full credit just because you did use the same process. So I'm going to do 1 to 5,000 because I think my computer can handle it. Let's see. So I'm gonna go to first to home and create the numbers from 1 to 5,000 and so use fill series 5,000, and I'm gonna do series in columns. Okay, then I'm gonna do die 1, 2, 3. And then I'm gonna also link to sum 1, 2, 3. So you have to link everything correctly, your inputs and outputs. Okay. Then you are going to select everything, and to select everything, you first select the first row, and then you're going to press either Control Shift down arrow or Command Shift down arrow if you're using Mac. So for Windows, it's going to be Control Shift down arrow, and for Mac, it's going to be Command Shift down arrow. And then go to Data, and then What If Analysis, and then Data Table. Column input cell is going to be any cell, and row input cell is going to be empty. So there are all of your simulation. And now what I wanted is histogram, right? So I wanted histogram for sum of 1, for sum of 2, and sum of 3. Now to create the histograms, I'm going to create the bin and frequency. of sum of 1. So you can do it multiple ways. You can create separate frequencies and bins, and you can also create one bin and different frequencies. I'm going to just create one bin and different frequencies, but I have to be mindful that I am covering the minimum of sum of 1 to the maximum of sum of 3 in my bins. Frequency of sum of 2 and frequency of. Okay. So as I said, my bin should start from the minimum of sum of 1 and it should go up to maximum of sum of 3, right? So I don't need to calculate the minimum of sum of 1 because I know the minimum of sum of 1 will be 1. But if you want, you can calculate. Just because if you roll a dice, the minimum that you would get would be 1. And the maximum sum of 3 is going to be 18 because if you roll 3 dice, then the maximum that you can get in all 3 dice would be 6. And that would be the sum of 3 then would be 6 plus 6 plus 6, which is 18. So I'm going to start my bin from 1 and I'm going to go till at least till 18. So I'm going to do this plus 1. And I'm going to go at least till 18. I'm just going to go to 19. And then the frequency formula, frequency first. So this one is the frequency of sum of 1. So frequency, and then I'm going to select all my sum of 1. With Control Shift and down array, and then all the bin. Similarly for frequency of 2, I'm going to select all my sum of 2. And the bin. Okay. Yes. And for sum of 3, all of my sum of 3 and the bin array. All right. So now we are going to create our histograms. To create histogram, you should only select your frequency and you should select till the bin that you have created, right? So I've created bin till 19. So I'm only going to select the frequency of the first 19 and then go to insert and then you're going to do a chart. Actually, I'm going to just select, sorry, excuse me. Then do a column chart and this is my sum of 1. And then again, another column chart, insert and column for sum of 2. And then again, another one for sum of 3. And that's about it. So if you do plot all these 3 graphs, you're going to see that your sum of 1 distribution was more uniform, right? You have almost equal frequency for each 1, 2, 3, 4, 5, 6. As for sum of 2, it became more like a cone, right? And then for sum of 3, it is becoming more like a Gaussian shaped or a bell-shaped or normal distribution. So the central limit theorem says that if you add more identical and independent distributions, the sum will converge to a normal distribution. So any distribution that you want to add, as long as they are independent, identical meaning that they're the same distributions, then the sum will converge to eventually normal. So this is just a cool empirical proof of that theorem. All right, so going to part 2, Brinkley. All right, so in Brinkley, what we are going to analyze is our profit per unit, right? So we are we have a selling price for the product, which is deterministic input, and we have three random inputs, right? So we have the procurement cost, the labor cost, and the transportation cost. Now, all these three costs are discrete random variable with such probability distributions. So for example, for procurement cost, the probability distribution is this, which means that you're gonna, the cost is going to be $10 with probability 0.25, $11 with probability 0.45, and $12 with probability 0.3. Similar to labor cost is discrete distribution with this probability distribution, and transportation cost has a discrete distribution again with this probability distribution. All right, so the first thing to do would be generate these discrete random variables. And to do that, we need to use a table like this. So the first thing to do is to actually calculate the lower end and upper end of intervals in this table. So we basically need to just populate this table first. How to do that? Again, you can follow your cheat sheet. It's basically you start with 0, and the upper end is going to be your lower end plus the associated probability. Then the next lower end is going to be the last upper end. And after that, you can basically drag it down because it's going to be the same formula. I'm going to drag down that one and then drag down this one. Okay, so once you drag it down, if you start from 0 and end at 1, that means you have done it correctly. Similarly, you should populate the next one. So you're going to start with 0. This plus equals to last one. And then you're going to drag it down. And also drag this down. Okay, again, you start at 0 and you end at 1. So over here, you're going to start at 0. This is going to be 0 plus probability. And you're going to, again, go in upper level, upper end interval, and you can again drag it down to get 1. So again, if you start at 0 and you end at 1, that means you have done it. Now to generate the discrete random variables, you're going to use the VLOOKUP function, VLOOKUP. The lookup value is going to be a random value between 0 and 1. The table array is going to be the corresponding table array. Make sure to include the cost for sure. The probability you can include or leave it out, it doesn't matter. And then finally, the column index is always going to be 3 in this case because the cost is in the third column in this table and you want cost, right? And then the match is going to be an approximate match because you cannot find the exact random number in this table. And that's about it. So for the next one, similarly using VLOOKUP function, lookup value is rand. Table array is going to be this array. Column index is 3, and the match is again true. Again, this one is VLOOKUP. Lookup value is rand. Comma, table array is going to be this one now. Comma, column index is 3, and it's true. Okay, so next up the simulation. I'm gonna do 1 to 1000. So start with 1 and then fill. Series 1000. So it's filled up with 1000. Now finally, I think my computer is getting slow because of the 5000 simulations, but we'll keep going. And then I'm going to link my procurement costs labor cost, and transportation cost. And finally, profit per unit. All right, now select everything and go to data, what if analysis, data table, and row input is going to be empty and column input is going to be any cell. Once you do that, you should have everything. Okay, looks good. Just to be consistent, I'm going to make all my profits as $sign. So I'm going to make it currency. All right. So now, as for my statistics, I'm going to start with minimum of my profit per unit. Maximum of profit per unit. Average profit per unit. Standard deviation, STDVS, profit per unit. And finally, I'm asking what is the probability that the profit will be less than $5, right? So I'm just going to do equals to count if the profit is, and my criteria is less than $5, right? So I'm going to count if within quote is less than 5. And I'm going to divide that by 1,000 because I have 1,000 simulations. I'm counting how many of that 1,000 times the number is less than 5, and I'm dividing that by 1,000 to make it a probability. And there you go. Your number should be somewhere between 0.07 to 0.1. And I'm going to make it a general format because it's a probability, it's not a $sign. Finally, creating histograms. I'm going to start with my minimum. And my suggested bin width is 1. So I'm going to be like, next one is going to be the previous one plus 1. And then I'm going to go till 12 at least, right? Okay. Now I'm going to use the frequency function. Profit per unit, comma. And then your bin. Finally, to create the histogram, selecting your frequency and then going to insert, and this is your histogram. Finally, what you have to do is you have to change the x-axis, right? Because it's not 1, 2, 3, 4, 5, it's your bits. So to do that, I'm going to select the histogram and go to chart design and then select data and then horizontal axis edit, and you are going to change your levels from 1 to 3, 4 to 3 to 15. Click OK, click OK, there you go, that's your histogram. All right, so the last one is the anime. And for that one, the only random input is your demand. Everything else is deterministic and all the formulas are in place. So the only thing you have to do is to generate the normal demand and then do the simulation. Right? So let's do that. So if you look at the question paper, I say that the demand is maximum of 0 and a normal random variable with mean 500 and standard deviation 300. So which means I'm going to do max of 0, comma, norm inf, which is the way to get normal random variable, then the rand function, then your mean, then your standard deviation. Oops, yes. So I'm missing, yeah. Wait. So there you go. So your demand is going to be 0 if this normal random variable gets a negative number, right? And your demand is going to be the normal random variable if that is more than 0, right? So if it's positive, then it's that number. If it's not, then it's going to be 0. All right. So I'm going to start with the simulation trials again. So simulation trial, and then fill it up to 1 to 1000. Hope this works. All right, it's a little slow, but okay, there you go. So I'm gonna link my demand. I'm gonna link my order quantity profit to 70, and then I'm gonna link to profit for order quantity 1000. Select everything on, Control Shift down arrow, and then I'm gonna go to data, what if analysis, data table. Column input say is going to be this, and just wait. All right. Okay. So again, I'm gonna just make everything $sign just to make everything consistent. So just go to home and make it currency. So now these are the statistics for order quantities. My minimum is going to be minimum of order quantity 300. Maximum is going to be max of the order quantity 300. I mean profit for order quantity 300, and then average is going to be average of profit for order quantity 300. Standard deviation is going to be standard stdv.s profit quantity for 300. And finally, the 95% confidence interval. So in this case, so whenever I ask you a 95% confidence interval, that means that you have to give me a lower bound and an upper bound. So the lower bound in this case is equals to, you always start with the average. Lower bound is average minus, the formula is confidence.t, and then it asks you the alpha. Alpha is 0.05 because it's 95%. Standard deviation is the standard deviation. And the size is the simulation size, which means that how many trials did you do? So we did 1000, that's why I'm going to select 1000. Okay, and the upper bound is going to be average. Everything else is same. The only difference is now it's average plus instead of minus. Confidence.t, alpha is 0.05, standard deviation is this, comma, size is 1000. Okay. So same thing you do for 1000, minimum, maximum, average, standard deviation, and then the 95% confidence interval. Again, it will have a lower bound and an upper bound. So I'm going to first do the lower bound. That is going to be average minus confidence.t, alpha is 0.05, standard deviation is this, and size is 1000. And then the upper bound is going to be average plus confidence to t 0.05, and then standard deviation, and then the size. Okay, so there you go. There are all of your answers. And based on these two profit statistics, you would say that just based on the average, or more robustly based on the 95% confidence interval around mean, you are, for example, you are 95% confident that if your order quantity is 300, your profit is going to be between 158 to 183. Whereas if your order quantity is 1000, you will have you are 95% confident that you will have an average loss around 337 to 253 dollars. So based on this, just based on this statistics, you should decide that the order quantity 300 is probably a better deal for you. So I hope this was helpful, and all the best for the exam.